warahmatullahi wabarakatuh. Our topic is about hidden toxins in cleaning products. Actually, we have so many toxins that we are not aware of, but for this one, we will focus on 1,4-dioxane. So, introducing our group members, my name is Nuridayati binti Raza. And my friends is Nawar Shaza binti Abdul Hamid and Nur Amani binti Hussein. So, for the contents of our presentation, we will include the introduction, response, precaution, and conclusion. For the introduction, we will introduce 1,4-dioxane, situation and risk, and epidemiology studies involved. For the response, we will explain the response occurred in human body and associated adverse effects. For the precaution, we will introduce the precaution, regulation, or government act on the harmful effect of 1,4-dioxane, and we will conclude all about this presentation. So for the introduction, what is 1,4-dioxane? 1,4-dioxane is a synthetic industrial chemical that is completely miscible in water. It is a byproduct used in the cleaning product and the most harmful chemical that we found in cleaning products. Exposure of 1,4-dioxane can occur through ingestion of contaminated food or water, or even dermal contact, and also inhalation. 1,4-dioxane can cause acute, intermediate, and chronic effects to humans. And 1,4-dioxane has been classified by the EPA as likely to be carcinogenic to humans by all routes of exposure. And studies have shown that 1,4-dioxane could give effect to the body system and sometimes cause death. These are examples of cleaning products that contain 1,4-dioxane, which are familiar and common in Malaysia. So, as the example is Tide Original, which contains 14,000 parts per billion or 14 parts per million, which have high level of 1,4-dioxane. And then 2 times Ultra Evolution Gentle Care, which contains 11,000 ppb or 11 ppm. Then next, Pantene Pro-V Fusion, Ajax, L'Oreal Elva Total Repair, and also Johnson Baby Shampoo for baby products also have the 1,4-dioxane, which contain 870 ppb. Epidemiology studies of 1,4-dioxane include the retrospective and prospective cohort were conducted since era of 90. These studies are conducted to human and animals to observe the health effect by exposure to 1,4-dioxane. From these studies, the researcher found out the lethal dose and the low observed adverse effect level for animal and human. Okay, for epidemiology studies for inhalation and dermal exposure, there are human studies have been reported for the cases that a worker exposed to 1,4-dioxane only for 1 week and whose post-mortem examination showed the kidney and liver alteration. Actually, the situation is the worker work in the room that have average concentration of 1,4-dioxane is about 470 ppm without exhaust ventilation and was not provided a respirator. And this case is also considered as a dermal exposure since the worker used the liquid of 1,4-dioxane to keep his hand free of glue. And then next is human animal studies will observe the effects to the body system involving carcinogenicity and cytotoxicity. So the inhalation of 1,4-dioxane in animals, the researcher has reported the results of serious low values, very different animal species for rabbits and for mice. And in the study through dermal exposure, the lethal dose for rabbit has been reported for 7,600 ml per kg. And meanwhile, low observed adverse effect level for pig is 143 mg/kg and rabbit for 57 mg/kg. Next is epidemiology studies for oral exposure. So this exposure, no studies were reported for death in human actually. And then, however, studies in animal have reported lethal dose in various species, so such as lethal dose for rats. There are some lethal dose that have been reported by a researcher So here I will read the letter dose for green apple. It's 4033 mg/kg. And then also, the researcher also do animal studies that observe the health effects, such as the what called immunological effect and carcinogenic effect. And the researcher observed the low observed adverse effect levels value is varied for different species.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Amani binti Hussein, and I will explain to you about the response occurred in human body and associated adverse effects of the 1,4-dioxane. So the first one is I'm gonna explain a little bit about the toxicokinetic of 1,4-dioxane, which is absorption, distribution, metabolism, and elimination. So the first one is absorption. So as Hidayati have mentioned before, there are three ways 1,4-dioxane can enter our body, which is dermal, inhalation, and oral. For distribution, currently no data available for the distribution of 1,4-dioxane in human tissues, neither data available for the distribution of 1,4-dioxane in animals following oral or inhalation exposure. For the metabolism of 1,4-dioxane, it is metabolized by cytochrome P450s, possibly of the 2A and 2D family. Induction of the cytochrome P450 enzymes increase the rate of hydroxyacetic acid HEAA formations, whereas inhibition decrease HEAA formation. And based on a study, repeated oral administration of 1000 mg per kilo of 1,4-dioxane induced its metabolism in rats, but at doses of 10 mg per kilo, no such effects was observed. At a single oral dose of 20 mg per kilo in mice, the metabolism was so rapid that 1,4-dioxane could hardly be detected in blood. Saturation of metabolism seemed to occur above 200 mg per kilo. The last one is it has been suggested at high dose, presumably reactive metabolites of 1,4-dioxane, B-hydroxyethoxyacetaldehyde (HEA), might be responsible for the cytotoxicity, including toxicity and carcinogenicity in experimental animals. Okay, the next one is the diagram of suggested metabolic pathway of 1,4-dioxane in rats done by a researcher before this. The proposed pathway are based on the metabolites identified. The enzymes responsible for each reaction have not been determined. The proposed pathway do not account for metabolite degradation to the labeled carbon dioxide identified in expired air after labeled 1,4-dioxane exposure. So this is 1,4-dioxane, this is HEAA, and this is HEA. The next one is elimination and pharmacokinetic of 1,4-dioxane. Based on the diagram, after 5 hours of exposure, the metabolites was measured for the first time. 1,4-dioxane was excreted in urine as the metabolite HEAA over the next 24 hours, of which approximately 50% during the first 6-hour period. In human exposed for 6 hours to 180 mg of 1,4-dioxane, which is approximately 50 ppm, 99.3% of the absorbed dose, assuming excretion was the only excretory route, was eliminated via the urine as HEAA. The remainder was unchanged of 1,4-dioxane. After the 6 hours exposure period, the plasma 1,4-dioxane concentration decreased exponentially, indicating that the elimination was not saturated. The plasma elimination half-life was 59 minutes. So the next one is health effects of 1,4-dioxane to human especially. So this is the diagram I include in the study. We show 1,4-dioxane exposure concerns from the source to receptor. As we can see, production workers, general population, and ecosystem can be affected by 1,4-dioxane. So before I explain more about the effects of 1,4-dioxane, this is the easy picture of the health risks associated with 1,4-dioxane in drinking water and consumer products, which includes cancer, liver and kidney damage, lung irritation, and lastly, eye and skin irritation. So actually, the effects of 1,4-dioxane on human health depend on how much 1,4-dioxane you are exposed to and the length of exposure. So it divides into short-term and long-term. For short-term, nose and eye irritation was reported by people exposed to low level of 1,4-dioxane over a short period of time. Exposure to a very high level may cause severe kidney and liver effects and possibly death. For long-term, effects mainly nasal cavity and liver and kidneys. Swallowing liquid 1,4-dioxane or contaminated drinking water or having a skin contact with its liquid form also affects the liver and kidneys. So this is the chronological effects of 1,4-dioxane based on the study research. First one, there must be an exposure of 1,4-dioxane, which the most common is through inhalation, dermal, and the least one is ingestion or oral. Airborne 1,4-dioxane for periods ranging from few minutes to 6 hours produce eye, nose, and throat irritation with minimum exposure concentration of 50 ppm. Based on the study, subjects complained of gastrointestinal pain, high blood pressure, anuria, leukocytosis, and also exhibited signs of nervous system involvement. Death occur 5 to 8 days after initial symptoms of the illness. So, lastly, postmortem evaluation revealed extensive liver and kidney damage, and in 3 over 5 cases described in one study, kidney disease was considered to be the direct cause of the death. Although no information was available regarding reproductive, developmental, or immunological effects specific to 1,4-dioxane in humans, some occupational study of workers exposed to 1,4-dioxane in combination with other solvents have reported elevated rates of spontaneous abortion, stillbirth, premature birth, and low birth weight. These effects cannot be attributed either solely or in part of 1,4-dioxane. So the next one is, can 1,4-dioxane cause cancer? Based on our reading, dioxane was first reported to be carcinogenic by Argus and co-workers. Fast forward, at the end of their experiments, 6 rats were found to have hepatocarcinomas, while 1 had additional tumors of the kidney and leukemia. The latter two cancers judged to not be treatment-related. The paper went on to hypothesize that the mode of action for tumor induction by dioxane involved denaturation of cellular micromolecules with resulting changes in morphology of endoplasmic membranes, causing change in the conformation and thus activity of the individual enzymes. According to studies, there are no absolute studies available that can indicate whether 1,4-dioxane can cause cancer in human. However, we can see laboratory rats that breathe vapors of 1,4-dioxane during most of their life have developed cancer in their nose and in their abdominal cavity. They also develop benign tumors in their liver. Laboratory rats and mice that drank water, which is through oral, containing 1,4-dioxane during most of their life, have developed liver cancer and also developed cancer inside their nose. Some scientists believe that 1,4-dioxane may cause cancer by a non-genotoxic mechanism. Scientists are debating the degree to which the findings in rats and mice can apply to exposure situations commonly encountered by people.
Okay, next is for the precaution and prevention, which aims to avoid any toxicity effect of 1,4-dioxane. So the first thing we should consider doing is to minimize usage of any product containing 1,4-dioxane, whether it is cleaning product, cosmetic, or even drinking water that may contain 1,4-dioxane. So if you know that these certain product contain 1,4-dioxane, so avoid it or minimize it. Other than that, we also need to avoid or minimize skin contact with cleaning product that contain 1,4-dioxane. And remember to wash your hands thoroughly after contact. And most importantly, do not breathe in the vapor, because it might cause irritation to respiratory tract. In some products, 1,4-dioxane only exists as contaminant, so they're not written on the ingredient list, although it is actually there. So what do we need to do if we want to know whether it has 1,4-dioxane or not? Look again in the ingredient list. If it does contain substances like sodium lauryl sulfate, PEG compound, chemical that include clauses of xylol, cetiaryl, olive, then there is high chance that it has 1,4-dioxane. So we should avoid products that contain these substances. The next thing to do is do not wear wet clothing right after washing it with cleaning product that contain 1,4-dioxane. This is because there might still be leftover 1,4-dioxane on the clothes, so contact with skin might cause irritation to skin. Last but not least, if 1,4-dioxane is used as chemical in laboratory, then we should follow the correct instruction of usage and always wear appropriate PPE. Next one is for the regulation and recommendation. Some organizations like EPA, Occupational Safety and Health Administration OSHA, and the Food and Drug Administration FDA, these are some of the federal agencies that develop regulation for toxic substances. They provide valuable guidelines to protect public health. Some of the regulation and recommendation for 1,4-dioxane includes the level of 1,4-dioxane in drinking water that is set by EPA, They has determined the exposure of 1,4-dioxane in drinking water at concentration of 4 mg per liter for 1 day or 0.4 mg per liter for 10 days. It's not expected to cause any adverse effect in a child. Next is level of 1,4-dioxane in workplace air that is set by OSHA. They set a legal limit of 100 ppm of 1,4-dioxane in air average over an 8-hour workday. Next is the level of 1,4-dioxane set by NAS, which is National Academy of Science, that established a maximum specification of 10 ppm for 1,4-dioxane in the ingredient polysorbate, which is a food additive. Next is the level of 1,4-dioxane that is set by FDA. They considered 10 ppm to be an acceptable limit for 1,4-dioxane during its evaluation of spermicide and 9 in a contraceptive sponge product. They also set a limit of 1,4-dioxane at 10 ppm in approving glyceride and polyglyceride for use as excipient in products such as dietary supplement. Okay, next is the government acts for its harmful effect. It's actually mainly about law that is developed to control usage of 1,4-dioxane. So these are some of the law developed in foreign countries for 1,4-dioxane. In United States, International Agency for Research on Cancer and US Department of Health and Human Services has determined that 1,4-dioxane is possibly a substance that can cause cancer in humans. So, the Occupational Safety and Health Administration, they established a workplace exposure limit for 1,4-dioxane, which is 360 mg per cubic meter or 100 ppm for an 8-hour work day, 40 hours per week. Next one is, in 2019, New York, they become the first state to pass legislation mandating the removal of 1,4-dioxane in product. And in 2020, they approved the strongest drinking water standard for 1,4-dioxane in the nation. In 2019 as well, they passed a bill to ban, passed a bill to ban the sale of cosmetic with more than 10 ppm of 1,4-dioxane as of the end of 2022. This law also prevents the sale of household cleaning and personal care products that contain more than 2 ppm of 1,4-dioxane at the end of 2022. So they set a limit for the 1,4-dioxane in ingredient of product. Other than that, also in some countries, they ban usage of 1,4-dioxane in certain products. For example, like in Canada, they ban the usage of 1,4-dioxane as an ingredient in cosmetic. That's all. Thank you.
So as a conclusion about 1,4-dioxane, 1,4-dioxane is a toxic chemical to human. The toxicity of 1,4-dioxane can lead to carcinogenicity and cytotoxicity and sometimes cause death in a long time of exposure. Exposure of 1,4-dioxane could happen through oral, dermal, and inhalation. However, regulation, recommendation, and government act have been developed to control the usage of 1,4-dioxane by manufacturer. Manufacturer must avoid the use of 1,4-dioxane in cleaning product, which could expose the harmful effect to the consumer and the workers. And also, the consumer must be aware the ingredient used in the cleaning product from the updated news, since the manufacturer actually does not include it in the product's description. Thank you. Thank you, Dr.